So for first FRQ, you could see they say that 4 times 0 T10, water is flowing into a small tube at a rate given by the function f, defined by f of t equal at 10 here for the time 5 of 10. And water is leaking from the tube at a rate given by this, okay? We got L of t. So that means if you have a cup, okay, imagine a tube, it's a cup here, and the rate is f of t, s of t. The rate here is from 0, from 0 what? From, I'm sorry, I have to delete all of that. So the rate to the cup, it is a rate, it is not amount, it is the rate. So rate is like rate of change for that. So for 0 and t until 10, but from 5, yeah, from 5 t and 10, it leak. So the rate of the leak of the water, the leak from the tube is what? Is L of t. Okay, so that means f of t and L of t here, both of them are like enemy. Yeah, are like enemy. So for the rate, yes, for the rate of water in the tube from 0, yeah, from 0 until t until 5, the water that are still in the tube. But from 5 until 10, some of those are leak from the tube. So that means we can make piecewise functions. Yes, piecewise function of the derivative of w of t. That is, w of t is represent to the volume of the water in the tube. But for w prime of t, that is rate of water in the tube here. So then we can consider that w prime of t will be f of t if 0 t and 5, sorry, 0 t 5, for f of t minus L of t is 5 t and 10. That's it. So that's all for first question. Well, for not first question, but for our function from the top here. So let's say that at time t equal 3, there are 2.5 cubic feet of water in the tube. Write an equations of the locally linear approximation at w of w at t equal 3. Use it to approximate the volume of water at the tube at time 3.5. So in this case, they told you that at t equal 3, there are 2.5 cubic feet. So that means 2.5 cubic feet in this case, it stands for the volume of the water in the tube. So that means we can consider W3 equal to 2.5. Why? Why is that? Why we consider W3 equal to 2.5? Actually, they say that what the volume of the water in the tube is represented by here. So that is why it's here W of t, but they say that at t equal 3, it's 2.5. So then we can consider W of 3 equal to 2.5. Yeah. So W of 3 equal to 2.5, like cubic feet. So that means feet cube like this. Okay. So our goal is to find or write an equation for local linear approximation at Wt equal 3. So like I told you before, in this case, we should write a tangent line of Wt at t equal 3. So an equation for tangent line, it has two in it. It has two kind of those. First, it will be y minus y1, as you can see, that equal m x minus x1. But this equations, it doesn't fit in our context. It doesn't fit in our problems. So we have to change that to y minus y1 equal m t minus t1, which is t here. They represent to what? They say that at t equal 3, right? So that means t equal 3.3, yeah, and m here that represents to the slope of the tangent line. So that means if any tangent line touch any functions, so that will be w prime of 3. So that means it touched the w of t. So that means it touched the curve of w of t. So that means the slope here will be the first derivative at that point. So we can consider w prime of 3. And y1 here, y1 is the value that we got from substitute the value of t into the function, so which is w of 3. Okay, so our goal is to find 3 of this and this. Okay, so we can consider that. So here, then I'm writing this after that. So cut here, so right. So then the equations is y minus y1 equal m t minus t1, and then y1 here equal to w of 3, that is 2.5 cubic feet, and m here it equal to w prime of 3, right? So w prime of 3, in order to find the w prime of 3, you have to know about the w prime of t at first. So w prime of t, where is it? So because we have two w prime of t, first and the second one. But here they want to find w prime of 3, right? So you have to understand about this first. We have w prime of t. So that means t here, if t, the value of t, like from 0 to 5 or greater than 0 but less than 5, we have to choose f of t. Yeah. But if the value of t greater than 5 but less than 10, less than or equal, so we have to choose this. So that means we want to know about the value of the w prime of 3. So that means we have to choose f of t in this case. So here, and then, but we can say that, but here then what? W prime of 3 equal to f of 3. F of 3, because we choose f of t, right? We chose f of t. So that means it will be w prime of 3. And then f of t here equal to arc10, but f of t equal to arc10 pi over 2 minus t over 10. And then the f of 3 here will be f of 3 will be it's 0.9. And then we can write y equal what? Y equal 0.9 t minus 3 and plus 2.5. That's all. But we know the equation is this equation of the tangent line, and we can consider that w of t approximations to it's t minus 3 plus 2.5, and then they want you to find the w, use it to approximation the volume of the water at the tube here. So the question they ask you to do the approximate the volume of the water. So that means the volume of the water, which is w of t, right? W of t, while t equal to 3.5. But in this case, they want you to use the local approximation linear. So then we can just substitute here 3.5. That will be equal to what? That will be equal to 2.95. The approximation, so we have to use this. So this is the answer for our questions. That's it. For the second questions, they want us to find the w prime of t, right? So they want us to find the w prime of t. So at first we have to read that carefully. Why? Because if you read that, you can understand about the concept of the lesson as well. So here they want you to find the w seconds prime of 8, right? So in order to find the w prime w second here, you have to found the w prime of 8, and then you have to found the w of 8. Okay, but what we doesn't have this. You will be skeptical that why I said that we still not have the w of t. So this case, w of t approach to this 0.90 minus 3 plus 2.5 is not the exact expression for the w of t. It just an expression for the derivative. It just an expression for the approximation of wt at t equal 3. That's it. So we don't really need this, by the way, but we need this. Okay, we need w prime of 8. So in order to know or to find the w prime of 8, you have to have the w prime of t, right? Because w prime of 8, it comes from substitute the 8 into the first derivative. And then we have to choose between two functions. Okay? Between two functions. Which one? We have to choose this, right? Then this. Okay. So, yeah, we can do it now. So here, then at t equal 8, so w prime of t equal to f of t minus L of t. That will be what? F of t, we already know from the top here, it arc tan pi over 2 minus t over 6, right? Arc tan pi over 2 minus t over 10. And L of t minus here, L of t is 3.100 here, but it actually 0.03 20t minus t squared minus 75. Okay, so then w prime of t will be like this. So in order to find the w second primes of t, we have to derive it. So that will be w second prime of t equal. So that means you can see here this and this, both of them are different. Both of them are different functions, but we can actually apply the sum rule in it. So what is sum rule, by the way? Sum rule is like you derive one by one. Yes, one by one. And you know what? It's like arc of 10 here. The formula for the arc of 10, you have to understand arc of 10x. Arc of 10x is 1 over 1 plus x squared. So in this case, you can see it's x and x here. But for something not x, you can just multiply the derivative of that expression. Like you can see here, the add expression is pi over 2 minus t over 10. That will be 1 over pi, 1 plus pi over 2 minus t over 10 squared times pi over 2 minus t over 10 prime, and minus 0.0320 minus 2t, the derivative of that. So that will be 1 over 1 plus pi over 2 minus t over 10 square. It's actually negative 1 over 10. So that will be, you can just write negative 1 over 10 here. That's okay. And then minus 0.0320 minus 2t here. So w second prime of t will be like this. And then we can say w second prime of 8, just substitute 8 in that place. And the answer will be negative 0.8. I can say it is approach to negative 0.18. Okay, so the answer is this. So here we found that, and using the correct unit, yes, and interpret the meanings in the context of the problem. So the context of the problem, what is that? So in this case, the problem is talking about the rates, right? They told us about the rates of the water that flow into the tube, yes, and then we can just got w prime of t, yes, as you can see the piecewise functions. So we can just say w prime of 8, so w prime second prime of 8 will be rate, yeah, rate at the at which rate of change, rate at rate of the rate of change volume of water at t equal 8. That's it. So this is the answer for that. And then the last one is there a time? Yes, they want to ask, is there a time at which rate of change of the volume of the water in the tube change from positive to negative? Give a reason for your answer. So here, what does it mean? So you have 5, t and 10, right? So what it means here, at which rate of change of the volume of the water in the tube change from positive to negative. So that means from positive to negative. So in this case, I can say like, okay, here is t and w prime of t, and that 5 and 10. Is that your curve? So I can just vertical like this because it is easy to understand, I guess. And then it changed from here positive until to negative. It means like that. So that means in order to change from positive to negative, so that means there must be at least one value of t that cause the w prime of t equals 0. So that means before this, so w prime of t change from positive to negative, it must be what? It must be across 0. So the answer, so that means the question is, they want us to what? To find out that there is a value of t that w prime of t equals 0. That is the meaning of the problems. Okay, so we have w prime of t, because it shows 5 t 10. So then w prime of t must be f of t minus L of t. Yes, f of t and minus L of t. And then, yeah, and then what? Sorry, and then we can find, okay, and then that will be arc of 10 pi over 2 minus t over 10 and minus 3 over 100 here. I can say, yeah, 20t minus t squared and minus 75. So then here 5 and 10. Okay, so they just want you to verify or classify that there is t between 5 and 10 equal to 0. So there are two methods that you can do. First, you can make a graph of this function. So that means if you make a graph of this function, you will get t equal 5 point something. But if you don't do this method, you can just using the intermediate theorem. And what is the intermediate theorem? So the intermediate theorem, they say that if f of a less than c less than f of b, so that means there are at least t belong to a, which mean we can say t b, yeah, belong to t, that f of t equals c. So in this case, if you want to find anything between 5 and 10 equals to 0, you can just to find w prime of 5 and w prime of 10. So if you find you will get W prime of 5 will be negative and W prime of 10 will be positive. For this question, okay, you can just plug in by yourself. I'm sorry for not doing for you because I have to choose calculator, so I cannot use it in my iPad right now. So yes, you can find. If you find, the W prime of 5 will be negative and W prime of 10 will be positive. So that means we can consider W prime of 5 is less than 0 and less than W prime of 10. So then we can consider that. And then, so that means it's T belong to 5, 10, yeah? That W prime of T equal to 0. That's it. So, yeah. But for this case, I think I was wrong. This must be positive and negative. Negative here. Yeah, you know why? Because of what? Because they said that from positive to negative. So that means W prime of 10 must be negative. W prime of 5 will be positive. So my bad. I'm sorry for my mistake in this case. So here, we can consider this. That's okay. Okay, so that's all for that. Thank you for watching.